Everyone. There is already so much talk in the chat, so I'm just going to welcome people who have arrived on time. Who's here? Posey, Joe is here, Jeff's here, Rebecca's here, Izzy is here, Max is here, Maddie is here. Hi everyone. There are lots of people here. Also, was it last week? Have I lost track of time, or was it Jeff's birthday yesterday? It might have been Jeff's birthday yesterday. If it was, happy birthday Boxing Day. And if it was last week, I'm sorry that I've completely lost track of the weeks, but that's just what happens in lockdown. Anyway. Ooh, some people can't hear me. Could anyone... Is it only Rebecca who can't hear me? It looks like my end, you should be able to hear me. Yeah, it must be your sound... Rebecca somehow is off. But anyway, so thanks so much for coming. If this is your first time, this is an Aim High Live. And so I'm going to be talking about, I'm doing this one on science, and so you can ask questions whenever you want and steer the direction this is going to go in. This one is going to be about what is carbon and how do greenhouse gases work, which is one I wanted to do because even though... I don't know, like, I think this is something that a lot of people do know, but I also think that it's something that some people, it's talked about a lot. Like, people talk about carbon in the news, don't they? And yet, like, do we all completely know what people mean by carbon? And so I thought I'd just do one on this, and it's particularly encouraged by my sister, who was asking me about carbon, my twin. So here we go. Maddie's been watching stuff about renewable energy all morning, so this is perf. Okay, so first question actually, before we go into talking about these whales. So renewable energy is supposedly a form of energy that, well actually, what do you guys think? What is renewable energy? What does that mean? Renewable energy. What does it mean by renewable? So Maddie's saying when we don't run out of it, like solar. Pumpkin Master's saying, unrelated question, is it true the sun makes noise? The answer is yes, although we can't hear it because of the vacuum of space. Japan Maple is saying that renewable energy we can make forever. Rebecca's saying energy that can be replaced as quickly as we use it. Okay, so I'm going to pick up on Rebecca's the one there because that's really good. So it's a form of energy that you can, that is replenished, and Izzy said it as well, replenished on a time scale that we use it. So replenished on a time scale that we use it. Just make that smaller. I cannot see what's going on there, but there we go. Yeah, so renewable means replenished on a time scale that we use it, because like oil and gas and coal theoretically all get replenished. It's just not that fast. Okay, so renewable energy, the classic ones you think of are solar and wind, wave, tidal, all these kinds of ones. Which is the one that I'm missing? So biofuel, someone is saying. So biofuel, for those who don't know, is when you grow plants and then you burn them and then you use the same land to keep growing plants. And it's kind of, I don't know, biofuel is not necessarily the best one, because normally what you've got to remember about humans is that we live in a time when we really think that we understand the land and growing things, and we really don't. So for the last 100 years or so, the whole kind of science of soil has been, if we want to grow plants, then what is it that we need to put into the soil? So if you want to grow more and more plants on soil, then what do you need to keep putting into the soil? And this is going off on a little tangent about biofuel, because we're talking about renewable energy. So if you are joining late, this is an Aim High Live, and we're going to talk about what's carbon and how do greenhouse gases work. But yeah, before we get to carbon itself, we're just talking about renewable forms of energy and biofuel, and why our science of soil has been deeply flawed for a long time and still needs a huge amount of work, because we're still kind of living in the dark ages. So Rebecca's saying we need to put fertilizers in, and Maddie's saying the same thing. And Maddie's saying that fertilizers are bad because they poison the rivers. Okay, so you might have already learned, you might have learned at school about how fertilizers can be bad for the rivers, but actually, that's even that is kind of not telling the full story. So for many years, we have thought that you need to put fertilizers into the soil to replenish the chemicals and minerals that the plants use, so that plants can keep growing. But this is very much from a viewpoint of we need to give the plants what they want. And it's not from a viewpoint of we need to give the soil what it wants. And for far too long, we've not been properly looking after soil. And only very, very recently, like literally the last 5 or 10 years, have we started to realize that actually the soil is crisscrossed with these incredible networks of fungus that take hundreds of years to develop healthily, and that if you don't look after the soil, then the land will gradually degrade away. So biofuel is this idea that you just keep growing plants, pulling them out of the ground, burning them, grow more, pull them out of the ground, burn them. They use very unsustainable soil practices. So biofuel, whilst it's currently categorized as renewable, because it looks like we can keep growing plants within the timescale of human existence, it's not a good way of doing things in the long term, most of the ways that it's done, because the kind of plants that are planted are not looking after the soil, and people don't think about the soil. And this is something I'll come to on another live, the importance of thinking of soil as a living thing and storing carbon in soil. And soil is so much more important than a lot of us realize. Right. Yeah, Japan Maple is saying lots of soil is degraded. So about a third to a half of all the soil on Earth is considered to be degraded now. But it's nowhere near too late to turn it around. We can definitely turn things around for the better with soil. It's going to be a challenge, and we need people to learn more and to understand how to look after soil. So I'm really set on doing a live on soil, and it will happen soon. Anyway, so renewable energy. So I saw a few other ones coming in. The one that I was looking for was one beginning with H. Does anyone know what renewable energy I'm talking about? Let me see what people are saying in the chat. Hydroelectric. Yeah, cool. And Lisa is asking if I'm going to talk about ocean acidification. I am going to talk about ocean acidification. That is coming up. But first, before we get started on the what's carbon and how do greenhouse gases work, we're just doing a little talk about renewable energy. So yeah, hydroelectric is one of the classic forms of renewable. Now, people so hydroelectric, for those who don't know, and we'll just use one of these whales to illustrate it, is if you've got a river running down a hill, then let's say this is the ground and then the river is flowing on top of it. Then instead of letting the river carry on flowing down the hill, you block it with a big wall, in this case, the head of a whale. And then as the water builds up and up and up in a huge reservoir, you can then, this now is quite gruesome, but you can put a tunnel through, in this case, the whale. And then as the water kind of tumbles through this tunnel, you can drive a turbine and generate electricity. Now, why is this nowhere near as green as a lot of people think it is? What are the big problems with hydroelectric power? So hydroelectric is a pretty good power source in many ways, in that it's quite green, we're not burning fossil fuels and so on, but actually it's nowhere near as good as people think it is. Why? So Jeff is saying it wastes water, which I'm not so sure about actually. If anything, hydroelectric is creating more fresh water sources because we're building up more fresh water. This is a really common misconception. You might have heard in the media them saying that fresh water all over the world is running out. And actually, the truth is, the EU did a huge mapping project of the world. The truth is that fresh water supplies on Earth are going up. They're going up and up and up, mainly because people are damming more water supplies and building more reservoirs, which is kind of not at all what you expect, is it? But fresh water supply on Earth is going up on the surface. And okay, I need to catch up. Okay, so people are saying that some of the problems with hydroelectric are that fish get stuck. Jasmine's saying fish get sad. Yeah, that too. And Zoxy Harley is saying that emissions produced while building it. So that's also a consideration. Is that it's going to require a lot of the building will be hugely emissions intensive as well, especially if it's concrete. Concrete accounts for something crazy, like 8% of total global emissions are from concrete. And so building it out of concrete is also going to have major emissions. Seems to be some calls for top hats and otters. I know otters being upset with the creation of dams. And Sicto's talking about limited to water levels, and Zox Harley again is talking about habitat destruction. And now everyone's talking about top hat. I've just been putting top hats on animals because I think it makes them look smart. So where would this whale wear a top hat? I guess it would wear one here if it was going to look presentable for the party. Anyway, so one of the things that I think a few people touched on, but I'm not sure if anyone said it in full, and apologies if you did, because the comments coming in really fast, is that when you submerge a huge region with water for the first time, there's often a lot of vegetation there. Huge amounts of vegetation, be it just grass or trees or whatever, that get flooded when you first build the dam. And as this rots, it produces huge amounts of methane. And methane is one of the worst greenhouse gases that exists. And so actually the construction of dams produces huge amounts of methane. And it means that overall, if you take all the calculations for hydroelectric over the short to mid-term, actually they're pretty bad for emissions. Like hydroelectric is one of the worst of the kind of renewable power sources, and not to mention the fact that you're preventing rivers from being free flowing, which means that you're destroying all kinds of creatures and biodiversity. So and there have been things that have been made to create these kind of like salmon ladders, so that in theory salmon can swim up the side of the dam, up this kind of obstacle course thing. And it was designed in a ways where people really thought the salmon would want to swim up it, and lots of things have been designed to try and let creatures go through the dam, but they just don't seem to work. Like, creatures are not adapting fast enough to this very sudden change in their environment when they suddenly come up against this huge wall. And oh my god, there's this amazing thing on the internet that everyone needs to check out afterwards, which is called a salmon cannon, which is what a lot of volunteers sometimes will go down to dams during the salmon migration seasons. For those who don't know, I think it's only one N actually. For those who don't know, salmon are a species of fish that swim upstream when they go to mate. So they come from the sea, which is amazing that they go from salty water to fresh water. They come from the sea and they swim right the way up the rivers, literally jumping up waterfalls and so on. Anyway, when they reach dams, they can't get any further. And so people all volunteer to run salmon cannons, where they literally like load salmons into these cannons and then like fire them over the dam, so that they can all get up to their breeding spots, which is unbelievable. Anyway, so where are we going? I'm just going to grab that. Okay, there's so many comments that come into the chat. So what I'm going to do is I'm going to read the chat and catch up on it. But first, I just wanted to ask, because this was going to be the thing that I was going to start with, but now we've well and truly gone into resources and stuff. If people might have already seen the live that Henry did about whales and why NASA needs sperm whales. But do you guys know what's going on with these whales here? What is going on with the whales? What are they doing? And how long are they doing it for? And those who saw Henry's live might already know the answer to this. Anyway, I'm going to catch up on the chat just a moment, because there's been so much that's come in. So Izzy's talking about how some organisms need the dynamics of a river that's free flowing, which don't happen with dams, because dams not only separate the river environment, but they also prevent the rapid flow of water that many organisms depend on for their survival. So yeah, whenever humans go in and drastically meddle with a region, it causes all sorts of problems. And that's why I used to think that hydroelectric was like, yes, great solution, let's build dams everywhere. And then I looked into it more and I was like, oh, actually it's really a balance, because it is much cleaner than other power sources in many ways, but we need to make sure we actually keep quite a lot of rivers free flowing so that nature can continue to exist in the ways that it has done, because when you meddle with things, you mess stuff up. And Jeff is talking about how methane isn't actually that smelly, it's the sulfur or something. Yeah, sulfur is normally the thing that smells. My uncle once created like a hydrogen sulfide machine that released like the egg smell, and he just like left it underneath the floorboards in his school back in the day. He was always encouraging me to do the same thing. Thanks Zoxy Harley for saying that. That's really nice. Okay, so Toby's talking about back in the 70s, there were huge parades against building giant hydroelectric dams. That's how your grandparents met. That's so cool. Yeah, that's the thing, is that like hydroelectric, it's really difficult to... It's like there's a big campaign at the moment in the UK about HS2, the high-speed railway service. And lots of people don't understand, why would anyone campaign against a railway? Because railway is good. We're going to get more people on public transport travelling at high speed instead of using the roads. Surely that's good. The problem is that like HS2, the railway line, is going to be built, and now it is seemingly going ahead now. It's going to be built through loads of ancient forest, and the ancient forest is going to be completely wiped out, and it's loads of habitat that will be completely irreplaceable. And that's often the decision that's taken with hydroelectric dams, is that you have to be really careful and you have to balance, like, is this going to make sense in terms of reducing our overall impact on nature, or will it make it worse? And Leonard's saying, is it sulfur dioxide? Normally hydrogen sulfide is the one that smells of eggs. And Lisa is asking, how could species adapt faster to dams? And the truth is that they maybe can't. Evolution only happens so quickly, and normally changes in the environment happen very, very slowly over hundreds of thousands of years. And so when humans come along and change things over the course of a few decades or a few hundred years, suddenly loads of species are like, can't survive anymore. And that's just the end for them. And that's why we are in the middle of the fifth mass extinction, where species are going extinct now. I think it's 1,000 times faster than we would expect them to if humans weren't around. So all species on Earth are going extinct 1,000 times faster than they should be, and which is why we have about 1 million known species at the moment on the brink of extinction. And it's because humans are changing things so rapidly. We need to get so much better at creating space for nature, because if nature collapses, we collapse as well. I really don't want to make it seem like things are desperately impossible to change, because we definitely can change things for the better, but certainly, yeah, things are, like, humans are changing things very rapidly at the moment. Anyway, so what have people answered about whales? Yes, the whales are sleeping. I am going to talk about carbon now. Sorry, this people have asked so many interesting questions on this. We're going to talk about what's carbon. But yeah, just before I do, I will say these whales are sleeping, and you can see the whole story on Henry's live about NASA and sperm whales. Why does NASA need sperm whales? They're only sleeping for an hour and 45 minutes, I think. I think it's an hour and 40. Of all the mammals on Earth, they sleep for the least time. What do you guys think? Which mammal sleeps for the second least amount of time on Earth? What do you guys reckon? Okay. I'm going to just catch up on the chat because it's gone so far. So Lisa was saying that by the year 2100, maybe 25% of marine life will be extinct. Well, that's the thing, about 50% of marine species depend on coral, and the coral is disappearing so rapidly that this is very possible. And Maddie's come straight in with the correct answer, which is giraffes. Giraffes sleep for the second longest period of time. Anyway, right, I'm going to talk about what's carbon now. To the actual thing. Wait, let me just grab this and hover it over the top. What is carbon, and how do greenhouse gases work? So something that always really confused me about greenhouse gases, and I think I mentioned this a little bit on another live, but I'll just go over it again. Something that always confused me is, okay, if greenhouse gases are these gases that like sit above us in the atmosphere and they won't let heat through, then why do they let heat in the first place? So obviously the heat is shining in from the sun. So with the sun's light, so does anyone know which colours of light, and I'm not talking about only visible colours, which colours of light are the ones that generally carry with them the most heat? What do you guys think are the colours that carry the most heat? Okay, so Lisa's jumping straight in with infrared. Jasmine's jumping straight with the actual answer. I'm just going to create a bit more darkness here. It's so bright. Bolzano's saying blue and Nihal's saying black. So black is the absence of light, so that's not a colour. Blue would give less heat, and white is the combination of all the colours we see. So if the colours we see are kind of ranging between red, orange, yellow. I won't fill in all the colours because I don't have time, so we'll just do red, green and blue. This is the kind of colour range that we can see across. So red, orange, yellow, green, and then blue and indigo and so on. The higher energy colours are this end, but the colours that carry the heat are this end. So these are the hot colours, and just beyond red, as some people were already saying in the chat, is the light that you might have heard of called infrared, which means beyond red. And yeah, infrared and red are the colours that carry the most heat. Okay, so someone already said this, so I know that some people will already know about this, so I'll go through. I'll go through as swiftly as I can. So yeah, so sunlight shines in, and this is mainly your red light and your infrared light that's bringing in heat. Now, the heat just goes straight through the greenhouse gases that are all layering up at the top of our atmosphere, and then it hits the Earth. Although it doesn't hit this side of the Earth because it's the dark side, I guess. Oh well, we'll have a patch of light on the dark side for now. Anyway, so this light hits the Earth and it heats up the Earth. Now, the difference is that when the Earth releases the heat back, it releases it in a slightly different colour. And this slightly different colour is absorbed by greenhouse gases. Now, for anyone who's finding it weird, the idea that the Earth is emitting heat and emitting light, just think about when you see a planet in the night sky. If you've got clear enough night sky, they look really bright, right? They've got so much light seemingly reflecting off them or shining off them. Now, not a lot of that light will be light that is literally just coming from the sun and reflecting straight off them back into our eyes. But some of it might be light that they're emitting themselves because they're not zero temperature. They do have some kind of temperature because they're being heated up by the sun. And yes, so the key idea about greenhouse gases is that they will absorb the sunlight. Now, it's okay. I'm going to do a really quick bit of chemistry here, which might lose some people. So if you've not done much on chemical molecules yet, for now just ignore this bit. But basically, carbon dioxide is like this, COO, and oxygen, as you might know, is more will drag electrons towards it. So here you've got between the carbon and the oxygen, you've got electrons bonding them together. And if you look at where the electrons exist in carbon dioxide, they kind of exist mostly over the oxygens and kind of less over the carbon because the oxygens drag the electrons off. And it's these molecules that have electrons kind of dragged to either side that tend to absorb greenhouse gases because the infrared radiation will make this cloud of electrons kind of vibrate up and down. So the cloud of electrons will kind of move around and it will cause the carbon dioxide to bend like this, like a seesaw, and will also cause it to kind of move like that and like stretch as well. And all of these kinds of ways that the light can hit the carbon dioxide and energize it then means that the carbon dioxide and other greenhouse gases will absorb this heat energy. So they'll absorb the heat energy here. And then what will they do with it? What do you guys think will happen once these greenhouse gases emit the heat energy that they've just absorbed? Where will it go? I'm just going to read a bit of chat here. So Leonardo's saying if there was no carbon around, there would be no life on Earth. And you're completely right. So life on Earth is completely dependent on carbon. We are carbon-based life forms. So much of our bodies and all the food that we eat contains carbon. Carbon is the central element to like so much of what makes us who we are. So let's see what people said. So Lisa X is saying because oxygen is polar, it's because oxygen is what we call electronegative. It pulls electrons towards it. It's not quite that oxygen itself is polar. Polar is what you get when it's kind of like this bit here is a bit polar because you've got more electrons here and less electrons here. But anyway, so people are saying back towards the Earth, send it out, and Max is saying send it out in random directions, and that is exactly the answer I'm looking for. So the sunlight comes in, heat energy is coming in, just goes straight through the greenhouse gases as if they're not even there, because it comes in at the right colour to do that. And then it hits the Earth, heats it up, and then the Earth re-emits it as a slightly different colour that is just the right colour, unfortunately for us, or actually maybe not, to be absorbed by the greenhouse gases. And when they re-emit it, they emit it in every direction, randomly. And because they do so, that means some of it gets directed back towards the Earth, and so that makes the Earth a little bit hotter than it would be if you had no greenhouse gases. Now, there's a question. If we had no greenhouse gases, so at the moment the average temperature on Earth is about 14.5 degrees. So the average temperature on Earth is about 14.5 degrees C. What temperature do you reckon it would be on Earth, approximately, if there were no greenhouse gases at all? So if there were no GHGs, greenhouse gases, what would the temperature on Earth be? What do you think? Internet of Things is saying minus a billion. The lowest the temperature could possibly go is minus 273. And that's the point at which you get something called absolute zero, where it's a theoretical point where all the particles stop moving. So Jeff's saying maybe 10. FTMP is saying very cold. Rebecca's saying minus 100. Okay, I like the guess that James is saying 0. It would be about, and again, like this is a bit of guesswork, but it's somewhere between minus 20 and minus 40, I think, is where it is. But basically, it's well below freezing. So with no greenhouse gases, the temperature drops well below 0. And Leonardo is saying that particles never stop moving. Well, that's the reason that you can maybe never get to absolute zero. But anyway, I should maybe do a whole live about absolute zero because it's such an interesting and weird concept. And it kind of doesn't make sense as something you could ever reach, but it's a cool thing to think about because weird stuff happens there. Yeah, so with no greenhouse gases, we'd be very, very cold. So we need some greenhouse gases to heat us up a little bit. But the problem is that what we've done is increase the greenhouse gases hugely. Now, before I talk about that, I just want to very quickly, because I realised I kind of missed it at the beginning, just say what is carbon. So when people talk about carbon in the news, normally what they mean is carbon dioxide. And many of you will already have worked this out, but I realise that that's quite confusing. Because when people talk about carbon in the news, they're talking about carbon dioxide in the atmosphere. When they say there's too much carbon being released, what they mean is that carbon dioxide is being released, and that actually it's normally coming from stored carbon. So if you take like a tree contains lots of carbon that is stored in a biological system. The best places to store carbon that exist are biological systems. They store carbon the most effectively and stabilize storing carbon as well. And when we burn things and do various other practices, then lots more carbon will be released. Now, another thing that you'll often see in the news that I wanted to just tell everyone what it was is this. Has anyone ever seen CO2 with a little E after it? And does anyone know what the E means? Because that's another thing that's important for understanding what people mean when they're talking about carbon in the news or just in the world. And Michelle is asking when this is finishing. It's supposed to finish around now, but I've just got a couple more things to say. They're supposed to last about half an hour, but normally they go about 5 minutes over. So it'll finish at about 5. Okay, so Maddie's saying maybe emissions. Daxar's saying maybe excited state. Who said the Internet of Things is saying maybe it's carbon dioxide from Yorkshire, CO2e. So CO2e. So Posey Joe is saying equivalent. Yeah, so the E stands for equivalent. Equivalent. So, as we were talking about in another live, there are loads of different greenhouse gases. So, as everyone was telling me before, methane is a way more potent greenhouse gas than carbon dioxide. when measured over 20 years, 100 years, what we call a short period of time. If you start looking at over thousands of years, then the methane starts to disappear, so carbon dioxide is a more potent greenhouse gas. But over a human lifetime, methane is far, far more potent. And so sometimes the potency of methane, when you release it, will be given as CO2e, as in how much is it equivalent to CO2. So often greenhouse gases are just given as CO2 equivalent. And that means that they're taking into account all of the greenhouse gases involved in the emissions. So, but it's a really weird thing because it depends the timescale that you're talking about it. So, you know, like, lobbies for the meat industry will try and use a CO2e number where they're looking at emissions over thousands of years, because that allows them to ignore methane, because over thousands of years methane is not an important greenhouse gas because it disappears. And so they'll say, look, you know, our CO2e is really low because we're not releasing much CO2, we're releasing, you know, methane and nitrous oxides and things instead. Whereas other people might use a really short time scale, and so they'll look at something like beef farming and they'll be like, whoa, you're releasing loads of methane, and so your CO2e is really high. But this is a very annoying thing because it allows people to kind of wriggle out of it looking like their CO2 emissions are very bad, if depending on the time scale that they're looking at CO2 at. Anyway, okay, so let's go. Let's just quickly go to here just to show you what's going on with carbon at the moment. So as many of you will have seen this before, this is what's been happening with carbon dioxide over the past 800,000 years. It's been going up and down and up, down, up, down, up, down, up, like that. Now I've shown this on one of the live as well, and the thing that I find really amazing is that it's only the times when the line has been above this, when it's been above this line, that it's not been an ice age. So all of this down here is ice age, and then all of above is not ice age, pretty much, approximately. And so most of the last million years or so has actually been ice age, which I found so baffling when I found it out. Anyway, this is what's happened since the Industrial Revolution. It has shot up. And so going back to that idea that we were looking at before with dams and how when things change very quickly, that's when it becomes troubling for living things. That is what has happened with CO2 in the atmosphere, and that's why the world is heating up what we describe as very quickly. Even though it doesn't feel quickly to humans, it is very, very quick in terms of the historical perspective. And also why other things are happening, like the oceans are what we call rapidly acidifying, because the other thing about carbon is that carbon, so when we talk about carbon, most of the time people mean CO2, the carbon dioxide is dissolving into the oceans, and when carbon dioxide dissolves in the oceans, what happens? What do you guys think happens when you dissolve carbon dioxide in the oceans? And the Internet of Things is saying, so the ice age is the norm, and that's exactly right. Ice age has always been the norm. Rebecca wants a petition to see my dog at the end of each live stream. I don't have a picture of him at the moment, but okay, I'll try and get a dog for the next live stream, if I remember. And Lisa is saying, does this mean that we're coming out of the ice age and helping it along? No, we've been out of the ice age. This graph is very, very small detail. It's all very bunched up, but for the last like 20,000-ish years, we've been out of the ice age. So actually, in many ways, we'd expect to start maybe going into another ice age within the next 20,000 years or so, but we're definitely not on course to go in that direction. And so we're leaving the natural cycle of the Earth. The Earth has been in this natural cycle for many, many years, and now we have entered this new age, which has a special name because we've affected the climate so much. What is the name of the new age? And also correct to those saying that as CO2 enters the ocean, it becomes more acidic. As CO2 enters the ocean, it becomes more and more acidic, which is also causing a rapid change in the ocean, resulting in rapid destruction of species and especially destruction of coral. And I would go into more detail about that, but I'm aware that we've run out of time. And so I'm just going to see what exactly the Anthropocene. The Anthropocene is the new era that we are entering because of the amount that we have changed the climate. Now, I am aware that this live, and thanks so much for coming, I'm aware that this live has been quite intense and quite been quite negative about the state of the world. However, I myself am very optimistic about what we can do about it, and I'm going to keep running more lives about about what needs to be done to change the world for the better. And so actually I'm going to try and do one a week on environmental stuff so that people can learn more about climate and the environment and how we can make things better. So please do come back for my next ones about this kind of stuff, because I really truly believe that by giving everyone a better understanding, we can start to change things for the better. So I hope you'll come with me on that journey. And Toby's calling for batteries again. Yeah, Toby, we were literally talking about batteries in the meeting before, and I do really want to do one on batteries as well, because that's such an important element of the of what needs to change for the better in terms of climate and so on. But yeah, thanks so much for coming, everyone. If this has been... Oh, in fact, I'll just put up what's coming up next. So this is what is coming up in the lessons for the rest of the week on Aim High. So do come along to these. Some of them are not mine. And let me know if that's too small to read. And but yeah, thanks so much for coming. Do sign up on the website to the mailing list so that we can send you the schedule every week. And if you're on the website, in fact, and you haven't done the survey, do fill out the survey that's below the live stream. It's so good to find out what works and what doesn't. So thanks so much. Because yeah, for those who don't know, we're a group of teachers doing this voluntarily during the lockdown to make learning a lot more fun. So I hope you enjoyed it, and do come back when we're next on. So yeah, tomorrow there's going to be Should We Be Paying Trees More Than Footballers? Am I the Same Person I Was Yesterday? Part 1, and this amazing live workshop on how to write a masterpiece in 15 minutes. So yeah, thanks so much. Do follow us on socials as well, because you can get updates on there. That's all. Oh, wait, I'm writing in the wrong place. It's all Aim High Live. And yeah, tell your friends about us too. And we will see you soon. Ciao. Bye-bye. Jeff's saying that you're going to City of London. Oh, cool. Yeah, did you keep sharing Elise's video? Anyway, we'll chat about that more later, Jeff, because I've got to run. But Daxter's not going to be the same person watching it. And thanks Internet of Things for the nice comment. And Mariella's saying, "Am I a school teacher?" I am mainly a science presenter, so I've done a lot of teaching, but I mainly do presenting of science. If you search up my name, which is, well, Matthew Shribman, you can see it on the website, then you'll see all my science presenting stuff as well. And yeah, thanks very much, everyone. See you again for the next one. See you tomorrow. Bye bye.